Okay, so today we're gonna like quickly just go over the whole MRS stuff. I don't think I did this before. Yes, okay, I did not do it before. Okay, so basically we have two goods, okay? We have food here and we have clothing here, okay? So right now, let's say that, okay, so I have like an income. Let's say my income is I. And now let's say we have like a price for clothing, and then price for food. Okay, so the total, and like this C will be like the number of food I can buy, number of clothing, and you know, F is number of, food I can buy. So to get the total thing, first of all, I am bounded by my income. I can't buy more than my income, and I also want to buy exactly where my income like exists. Like I don't want to save any money, I'm going to spend my money only on these two goods. So I equals P, the price of this clothing times the number of clothing, plus the price of the food times the number of food. So this will add up, this has to add up to my income because that's how much I have. That's how much money I have. This is kind of like a basic thing. We're just going to like, we're not even going to use this too much. So anyway, we're just going to write this in terms of, we're going to write it as like a y equals mx plus b with c on the y-axis and f on the x-axis. So we get, if you do this, you'll, like, whatever, I'm not going to do the math, but it's basically just like I equals, whatever, this over p C minus PF over PC times F. So here this is the y-intercept and this is the slope. Okay? So basically that means that, hold up, let me just scroll down. That means that if I have a line that goes like this and the line is I equals PCC plus PFF, that means that the slope equals negative PF over PC. So it's, instead of, it's a negative, obviously, because it's a downward sloping, right? And the maximum number of clothing I can buy with this thingy equals I over PC. And this sort of like makes sense like intuitively, because if I have like clothing, if I want to buy clothing and I have like $10, for example, and each clothing costs like $2, and I can buy 4. So dumb. I can buy 5 because 10 divided by 2 is 5. So that you get I divided by PC, the income divided by the price of the thing. And so without even like rearranging this equation, you know that the number of the x-intercept for the maximum number of food you can get is income divided by price of food. Like this. Okay, great. So this we have here, that's going to be our first thing. It's going to be like our first equation, okay? And just remember that this is the slope, okay? So that's our first step. Our next step is going to be IC curves. So we have this thing here and then we're like, yo, cool. And then which one is on the, okay, it's F on the bottom, C on the top. Okay, so you have F on the bottom, C on the top. Here's an IC curve. So basically this guy over here is like, hey, like if I want to, okay, right. So why the thing is shaped like this is, for example, right now, I already did a video on this, but I'll just do like another one here. So right now I'm at this position, at position A, I have like so much C and like so much C and less F, okay? And I'm like, yo, like I'm just kind of tired of C, like I don't want C that much. So right now at this point I would be like, you know what, I would give up so much C just to get one more F. Like for example, you know, I think it's easier if I think like, so I have so much clothing and I have so less food, so I'm like starving, right? Or if it's the other way around, it would, like if it's over here, it'd be like, oh, I have so much food, like I have nothing to wear. That, like that's also pretty bad. So now I want sort of like a balance. So at this point, at A over here, I would give up a lot of C. I would give a lot of clothing just to get one more food, because at this point right here, food is worth a lot to me because I don't have much of it. So at the end of the day, it's like variety is valued. I think that's actually one of the basic consumptions. Hopefully, yes, variety is valued. So that's why the IC curve is shaped like this. If it was shaped like the other way around, it would be like, yo, like I would give up a lot of food to get more C, which is not correct. So that is inaccurate. So this is why the thing looks like this. And basically, what we are going to do today is, where the hell is that thing? So we know that the slope is of the budget line is PF over PC. And then we're also going to do another thing with this IC curve, if I can just find my notes. Okay, so for the IC curve, I am at A, and then this is going to be my B, okay? So when I go from A to B, I lose some change in C, and I add some change in F. Okay, but since the since every bundle on an IC curve has the same amount of utility, that means that when I do negative change in C times the, so I get the same utility, right? So utility at A, hold on, let me just do this. Utility at A equals utility at B. So that means that at utility A, that means that when I decrease some utility, okay, so yeah, okay. That means that when I decrease this C and multiply it by the marginal utility that I get from C, this has to be equal to my increase in change in F times marginal utility F. Like basically what this means is the more utility that I get from each, like the decrease in the decrease in utility that I get from getting less C has to equal the increase. That way, like the total change is 0. Okay, whatever. Anyway, that's that. Hopefully that is. Oh, my bad. It's actually supposed to be like. Oh wait, yeah. Okay. So the thing is, since like the change in C is already like a negative thing, you don't need this negative sign. I'm just gonna take it out. So that's one thing. So now we can rearrange this to write it as change in C over change in F equals MUF over MUC. So this isn't really that helpful, unfortunately. Okay, whatever, we'll see. But you see, what we have here is, hold on. So, hold on a second. This is MRS. So right here we have this little thing, okay? Like this has to be satisfied. So, what the hell? What do you mean by this has to be satisfied? Alright, so this means that when I'm moving from A to B, when I'm moving from one bundle to another, this thing gets satisfied. Right, but okay, cool. So within an IC curve, we have different utilities. But since there is different like number of stuff that you're buying, like I have like different numbers of food and different numbers of clothing, the price thing, we also have to take that into account. So basically, for example, if I had a bundle over here, the price may be like, I don't know, price equals $6. Whereas a bundle over here, the price may be like $12 or whatever. So you have to like equate both two and stuff like that. Okay, hold on. So we have this, and so for some reason this says that this is another equation for MRS. Right, which actually kind of makes sense. Hold on. Marginal utility of C divided by marginal, okay, no, that doesn't make sense. Change in F over change in C. Okay, so marginal rate of substitution. Okay, I mentioned like in another video where marginal rate of substitution of A, not to be confused with the points A and B, of A for B has to be like, oh, so of A, so this is like the base unit, so plus 1 of A means how many less of B. Okay, so there's that. So that means that to buy one more A, how much B do I give up? So you can, oh, right, okay, cool. So you can write this in terms of the price. Like, for example, the price, if I, like, for example, if the price of, like, I don't know, like, the clothing is $2 and the price of food is $4. Okay, well, then price of clothing and then price of food. That means that if I want to get one more clothing to get plus 1 food, I will need to get minus 2 clothing, right? So I can, like, it would have to equals minus 2 clothing because it has to equal to, like, 2 times 2 is, like, -4 plus 4. So that's one thing, okay? So for the marginal rate of substitution, the slope thing has to be satisfied, which is PF over PC. So marginal rate of substitution equals PF over PC. That is one thing. Another thing is apparently this guy over here is, like this guy over here, is another expression for MRS, which feels like it should be like a very basic thing, but I'm not getting it for some reason. Marginal utility of food divided by marginal utility of C. Why is C on the bottom though? Because MRS, where we did PF over PC, that was what? Hold on. Let's say that PC equals 2, right? And PF equals 4. And I'm trying to find out the marginal rate of substitution of the x-axis, which is going to be, in our case, which is going to be, what is it? F. Marginal rate of substitution of F for clothing. So according to the formula, it would be MRS equals price of food over price of clothing. What? I could have sworn it was the other round around. Oh, right, my bad. Right, so F is on the x-axis, that's why I surround the other. Okay, so price of food is 4 divided by 2 equals 2. That means that to get one more F, I need to give up 2C, which is also what we just did right here. So that makes sense, right? So we know this thing, MRS equals PF over PC. That is one thing that we have confirmed. Another thing, okay, so we're back to here. So MRS is like, yo, how much MRS of, is this maybe the other way around? All right, yeah, if I just switch around the thingies, it would be different. Hold on. But then, MUF, PF, yeah, okay, never mind, it has to be this way. Change in C over change in F. What do we have here? We have like this guy who's like, yo, MRS equals, no, hold on, I don't get it. I feel like it's a really basic thing, I'm just not getting it. Will vary depending on the 19th unit or 20th unit, yeah, whatever. So another expression for MRS. Why is another expression for MRS? I mean, it's sort of like marginal rate of substitution is, and this is the same thing, of F for C. So like how much F would I give up? I mean, how much does one food, how much do I value one food, right? So if, hold on, change in C over change in F, you know, I guess instead of comparing it to this part of the equation, if we compare it to this part, I think it might work out better. So MRS, so marginal substitution, like how much does 1F equate to 1C? Well, first of all, what I'm saying is, yo, like if I'm going to change my C by some amount, and then I change my F by some amount, let's say like, I don't know, like 6 divided by 3, just for simplicity, that would give us 2 over 1. That means that I would give up 1, okay, cool, that makes so much better, right? Because the change in F over the change in C is basically like how much would I give up, right? Whereas the marginal utility is just like the equation, like the equating, like the equal version of it. But anyway, if you think of it in terms of this, it's like, yo, like my change in F has to be on the bottom because the denominator is going to be like the 1 base unit. So over here we have change in C over change in F equals MRS. And since this is equal to this, so MRS equals MUF over MUC. So I guess this makes sense, like change in C over change in F. Well, first of all, it's like, yo, how much C would I give up? How much would I have to change C for me to change F? And then we bring that back here, and we get MRS equals PF over PC, which we found out like in the beginning with the budget line. It's also equal to the MU version of it, which is MUF over MUC. MUF over MUC. So there's that. So this is gonna be our like best bundle thing, like, or this is the bundle that we're gonna choose, like utility maximization bundle, UM bundle for short. So we have this, right? Do I have any notes here? Wow, I have so much notes here. I could have used this. Okay, whatever. Anyway, so yeah, this is this. What did I even make this video for again? Like, there was something I was confused about graphically. Okay, you know what? I'll come back to this later. Okay, thanks, guys. Bye.